Hello, my name is Goran Mankic. You're watching Tilda Center course on FreeBSD. And today is the day when we're gonna, for me, revive old memories. Uh, we're gonna go back to basics, how to do really basic stuff in Terminal, and find your way around and kind of give some meaning to the last week's lecture, what it all meant, hopefully, or at least some of it. We sent Man here as a manual for hierarchy of FreeBSD. He's gonna tell you what is where, but let's see. Let's see how do you navigate around. Uh, Unix, so inherently, FreeBSD is uh, everything's a file, and there is a hierarchy of these directories. So to list them, you can type ls or list them as a list, and you get something like this. And you can say, okay, how about I learn more about ls? And there is quite a few uh, options you can pass uh, to ls that is basically described here. Uh, and what is usually, you didn't see it probably last week, there is something called environment. I will get back to this in just a second. And usually towards the end, there's some examples of whatever you're reading about ls in this instance. So, man is your friend. Use it a lot. For me, coming from Linux environment and Windows, I used to search for answers online, but uh, man pages in FreeBSD are just really great, and there are three handbooks, like the handbook, Porter's handbook, and developer's handbook. So people of different skills can still learn some. Sorry, still can learn something. So uh, that's why I started with manuals, because they are going to tell you how to navigate around. And let's say I want to go to directory TMP and see what is there. This is how I would do it. And uh, to really grasp what is going on with the terminal, um, I myself use fish for the shell, and it has its own style and pros and cons. What I usually do is root account is always system shell, uh, slash bin slash sh, and actually I can run it and show it to you. So there is nothing fancy, no colors by default, no, basically nothing. And uh, The reason for it is because when you upgrade, part of upgrade is that your packages are old, actually built for the previous version of your operating system, and something might break, and you don't want that something to be your login, at least not for root. So this is basically how it looks, uh, and there is you will probably have to edit some configuration files or something like that. So let's go through it. Uh, there is there is one file that is like the main configuration, and that's where some of stuff lives. When I say some, something like this. And I like to organize uh, by these configuration files, not having all in one. And for example, there is something called virtual OSS. Not currently, not even important for this lecture, but this is how I configure it. So every service has uh, its own file. It's usually how you name the service file. That's how you name the configuration one. It's there is a correlation, and I want to show you that because virtual OSS comes from the packages, you can see that this is not etc rc virtual OSS. It has user local prefixed, and all packages in FreeBSD get their configuration from this directory, and the base system also has this. So whatever is in there, let's say mount D, right? So this is a system uh, service. It comes with a base FreeBSD operating system, and this one comes from packages. If there is user local at the beginning on FreeBSD, there is uh, you can be sure it came from packages. To be technically correct, it's either ports or packages, but we're gonna get there why there is a distinction and so on. What was the difference? For now, just imagine there are only packages, and we will get to that over time. So uh, this is basically uh, how you configure your services on an operating system. But actually, let's say I logged in as root. Yeah. And I want to edit, let's say, this configuration. It's not that important for what you're editing right now, but easy edit is, well, easy. And let's say I'm just gonna simulate some change. Simulating change because everything that starts with sharp symbol is a comment. And then when you press escape, it's going to give you a menu that actually means something, and you can move with the arrows. And you probably want to leave editor right now, so you press enter and you have to choose one of these two, press enter, and this should be changed. How do I know that? Because cat is command that is just dumping the um, contents of a file to a terminal. So it's kind of validation that I did my edit right. Now, probably you would like to. I'm not gonna do it with this service because it's gonna break my audio. But there is a service command that can tell you. I think right. Uh, that can tell you what is enabled on a system as a service, so that uh, you can restart it or enable it or whatever. So, for example, if you look at, okay, what can I, let's say PF, where no, it's here. Right, probably comes part as initialization of reggae, which I'm also going to talk about later, not in this lecture, but a few in the future. And one of the things it tries to help with is how to integrate your PF rules and your custom rules for the firewall, that is. So you can say service PF disable, and then you can see it found the right configuration file for you and change just that in the configuration file, right? So if I enable it back, it's it's here. But you can see that uh, always listing this file is not that great. I can use grep, which stands for doesn't matter. Actually, it comes with a history. Uh, okay, about real-time audio latency, I'm gonna go back to that real short. It's not a short answer, but it's a kind of nice one. Uh, so if you want to list only lines which contain PF as a string in this file, this is what you would do. And there is PF logging. Also, we'll come back to that later. And your your line that you're actually interested in. Right, but if you look at this one, you can see that it's in a different file, and if I disable it, it knows which file to use to edit the change, right? So it's no right here. And this is how, when people say you should enable or start a service, now, of course, you have restart or stop or start or uh, some services define um, extra commands you can reload, for example, for Nginx and so on. So this is how you basically configure uh, your services to start with boot or don't. So about real time and audio latency, uh, it's better than when I started with FreeBSD, which is 2016, and the reason that I switched is because Linux didn't have a real time thread queue, so and FreeBSD did since well forever. So I thought, okay, how about I give it a try because at that time I wasn't really happy with Linux and how it behaved with patches that enabled it real time. For example, VirtualBox would break, and VirtualBox module would break. So not a really nice situation. And I said, okay, I read online that FreeBSD has real time threads. Well, literally since forever, it inherited that from Unix, if I remember correctly. But I said, okay, give it a go. And there is a problem with scarce info about audio. I had to port some things. I contributed some documentation to the virtual OSS. Uh, as all documentation never enough, right? Uh, it would be nice that there are some other use case scenarios described in, for example, my man virtual OSS. So if you go to the end, there is few examples, but yeah, it can be better describing some maybe crazier situations and use cases. So virtual OSS is what you're probably gonna need if you have any I don't want to say serious use case, but more demanding one uh, concerning routing, and it does mixing in the user space, so it's kind of faster. So yeah, if you go for more advanced audio, you will probably use virtual OSS, and then well, this man page is your friend. Uh, there's a really cool examples and uh, some stuff and routing and EQing and compression and whatnot that virtual OSS can do for you. So it's becoming even a user friendly year, uh, meaning that with virtual OSS, for example, you can switch between the inputs and outputs that it uses, like a hardware devices for input and output. So it's neat when you need to switch between, I don't know, you have USB microphone and a Bluetooth headphones, right? It has uh, like a nice way to route audio from one device to the other, making other applications things is just one sound card, nothing special. Uh, Oh yeah, there's also Jack, that is huh, popular audio. Uh, I don't know how to call it. Framework, library, program, uh, and I am one of people who invest some time importing Jack 2 to FreeBSD, and it's ongoing uh, patching. Uh, it will be better, but that's really, really advanced audio. And for now, FreeBSD works with the Jack 1, which is not so terrible. Anyway, yeah, the audio scene is getting better and every day, but that's a bit of an off topic, and I can talk about it for well years apparently because I've been doing that. But let's get back to the basics, back to the primitives. Um, what I wanted to show you is, and I hope you have time to play with FreeBSD at least in a virtual machine. What I wanted to well, kind of scratch the surface here is what ZFS is, why do we kind of love ZFS, what it brings to the well, system administrator mostly. So there is a concept of a mount point in FreeBSD, well, in all Unixes. I think only Windows doesn't have that concept. But there is, when you type mount, there are different things, well, screaming it back at you. And they tell you what device is mounted on which directory. When I say mounted, that means if you go here and create some file, like to the root directory, that's gonna end up here. But you see, if you go over here, that's gonna end up on a different device. Now, this is a data set in ZFS, uh, but this can be different partitions with, doesn't have to be a FreeBSD native file system. It can be, I don't know, NTFS because you have a drive, USB drive that you want to carry around or something. So this doesn't have to be a ZFS dataset. It can be USB uh, mounted somewhere, wherever you choose to. And mounting basically means when I write to this directory, which device am I actually writing to? By device, meaning either uh, hardware device or some other uh, ZFS data set that the physical blocks are being written to. So you can see that it creates quite a confusion with the ZFS. There are a lot of data sets. All of this coming from Linux, probably all of this is just brute partition. Anyway, these are uh, probably, most certainly not organized in Linux like this. And there is really a lot of data sets because if you take a look, these are just ZFS data sets that are being mounted somewhere, and these are all the mounts of, for example, this is not ZFS, this is a special file system that exposes your devices, like, I don't know, keyboard or mouse or webcam or whatever. And these are all uh, data sets, right? So when I say a device, there is something mounted on a directory that uh, that the physical uh, blocks of file are being written to if that file belongs to this directory, right? Um, so let me show you why. I'm gonna scratch the surface here with ZFS and why it is so great to extend. There is something called ZFS Snapshot. No, let's first create something. ZFS create. Uh, so it's gonna tell you that okay, we need some more arguments and that the ZFS can yeah allow unallow. This is a really cool feature. Sorry. So bound point. I want it somewhere like no. Uh, here. Sorry. And I think this is the no. Sorry. This is the syntax. Okay. Now what I did here is created a uh, new data set, and when you list it, you can see it's here. So if I go to that lecture, it's empty. And let's say I create something .txt and I'm writing whatever. So I save this file and I can see it's here. I can check out the contents. And okay, so uh, it's like because when you type mount, you can see it's the last item in the list. It behaves like it's a new partition that is being, new device that is being mounted on top of this slash lecture. So yeah, when you ZFS list, you can see that they all have same amount of available space, and that is because they are sharing one uh, one drive. So wherever space is allocated out of these data sets, it's allocated in this what is called a pool. I don't want to go into what a pool is right now, but let's say it goes to the disk or a partition. Uh, so this, if this grows, all of them are going to lose some available space. So it's um, better balanced than the when you have hard boundaries of partitions. They're not so flexible, right? It depends where you allocate the data. So these are from a newcomer to ZFS world. This may look like a more flexible partitioning scheme to some degree, and it's not only that, and that it's not only that I'm uh, trying to provide an example. So uh, there is okay. If I say ZFS list, it's gonna give me um, data sets, but There is something called type in ZFS, and one of the types you can list is a snapshot. So you can see that I only have this snapshot. Doesn't matter what it is. I'm gonna create a new one for the lecture, and the way. Okay, let's say I don't know how to do that. Snapshot. Oh my god. Right. So you are probably no, you're probably gonna list it first. So this is what you want to snapshot, not the directory, but the data set. And because you're snapshotting data set, that's the argument. And you have to give a name to the snapshot, and you're gonna do that by adding @ and having, let's say, original. All right. So if you just list it, it's not there. But if you list it as a snapshot, here it is. And you can say, okay, give me everything, snapshot or otherwise. And you can see one snapshot here, and there is one snapshot here. I mean, different data sets being snapshotted. So they are what you people will usually tell you, and they're right. Snapshot is not a backup, but what I'm trying to say, it's a good thing to take snapshots and as a part of your backup. So just make the consistent snapshot of data to be backed up. So if your backup takes time, it doesn't matter if the data keeps on changing. I don't know if it makes sense, but I'll try to illustrate. Let's say I wrote some meaningful text here, and I saved the file right now. And if I list, let's say, just snapshots, okay, I can see that it's already using something, right? If I say give me all, there is something in this snapshot uh, that I think wasn't there before. Let's see. Yeah, this was 0, right? This was 0 bytes. And now all of a sudden there is this 56 kilobytes of difference. Now, I'm not going to go into why this size is as it is. I'm going to try to explain what's going on when you take a snapshot. What does it mean for the rest of the system? So the way ZFS works is that it's, let's imagine it like this. Your data is on a hard drive or SSD or whatever drive it is. And for some short amount of time, in seconds, I think like 5 seconds, ZFS is going to accumulate all your changes into memory, and it's going to accumulate them in a smart way so that when it writes the changes, none of the previous data is going to be overwritten. That means that ZFS kind of works like snapshotting all the time, but remembering by default only the last snapshot. Uh, if you want to be really technical about it, what I'm talking about is something called Uber block in ZFS. Uh, it's like uh, you can see that everything starts from root and it branches down as a tree. Files themselves are a tree-like uh, structure in a kernel on a disk and blah blah blah, but everything is basically tree alike, and there is uber block that is like a root of that tree, and when you actually do the snapshot, you point your snapshot at the uber block at some time, at some of the previously saved uber blocks. So when snapshot is taken, what happens under the hood that uh, that Uber block is going to be like saved for later. That's what's called a snapshot. And if like nothing references the Uber block, there are no snapshots, and it's not a current one that we're accumulating changes to. Uh, it's not going to be like saved over time. We have to tell ZFS when to save the snapshot and basically when to create a new pointer towards Uber block. Anyway, this algorithm, this uh, how to say this behavior that you don't overwrite all the data is called copy and write. So in a tree, everything is the same if there are no changes, and if you change something like deeply in the tree, you're gonna made a copy of that, change it, then relink it. But relinking means that your parent node or parent, however you imagine that linking to be, because I don't want you to be programmers at this time, but there is a connection between those nodes in a tree, and because you have to relink it, and that means changing the parent node. Also, the parent node needs to be copied and then relink to a new node. So everything from that, let's call it a leaf, up to a root, has to be copied, and then that small change with relinking done. Uh, there's no there's no too many levels from Uber block to whatever leaf is. So there's no like 10,000 blocks that you need to change just to change a small amount of text. But it does happen. It does have this little overhead, which gives us ability to uh, take snapshots really, really cheaply, meaning whatever is in the Uber block right now, that's my snapshot. And I mean, you can imagine under the hood, it's a little bit more complicated, but this is the principle how it works, how the snapshot is created. And the snapshot is read only. Now, you can say, well, what's good with read only? Um, if basically this goes to hell somehow, read only this might not sound like a good idea, but it's actually good because what what you want is to like point this, rewind this data set to a specific snapshot, and then keep on changing that one and leaving this one intact, read only. So if you make some mistake again, or maybe you're experimenting something, you can say that, okay, this is something I change and break. This is set in stone, right? That's how you behave with ZFS, how you work around it or with it, right? At first, it's overwhelming, and what I would expect anyone coming from Linux, for example, uh, seeing ZFS for the first time, it's kind of where is my data, what is going on, and what is taking up my data. Because if you delete everything in here, still snapshot remains. And it's weird that you watch, I deleted it, why isn't taking up space? Because there's a snapshot, or there are even more advanced techniques with cloning and whatnot that we're not gonna get into today. So uh, we have this snapshot, and you can rewind this to this snapshot. But before I do that, I want to show you something really, really cool. Um, and I need my files in a snapshot and this something txt to be different, right? This is meaningful text here, and there was is just some gibberish regex, if you like. And what I would like now is to create, let's call it, I don't know, something. Right? Now, I want to create a data set that is uh, basically created like a lecture, just given a different name and mount point. Right? If we list it right here, right next to this one. All right? And it's already taking up some space. Greedy one. Anyway, what I'm trying to say is that you can um, you can check it out, and there is nothing here, right? So for this experiment, for I will have to be in the well, not in something that's important. And ZFS has something that it calls send, and this is the practically this is the syntax. Uh, we can send one snapshot and receive it as another uh, in another data set, right? So what I'm trying to say is here that you can send like no wait. First, I'm gonna list the snapshots, and this is the one I want a ZFS send, and I wanna ZFS receive it on where is it? Okay, here. All right. Ha. Yeah. First time I need to overwrite it, and this is forcing the receive to overwrite whatever send is, well, basically sending. And before I show, well, okay, no. Now something txt is here, and it has this gibberish from the from the snapshot, not this somewhat nicer text here. That means that ZFS send produces exact copy, snapshot of the data that ZFS receive knows how to read and put into a different data set. Now, you may ask yourself, why didn't I copy files? And it's a legitimate question because that would do practically the same thing. The answer is sometimes this is faster. If you have a lot of small files, you know that your in the old days head of hard drive would go around and making it slow. Today, reading metadata and right, not huge chunk of one file is being transferred. That takes your bandwidth towards hard drive. Uh, ZFS doesn't work on files, it works on blocks. And those blocks are always the same size. And that's how ZFS is organized. That's how ZFS actually works. It's what it's, call it a native language. So this is what is called a pipe because left from this symbol is what is sending uh, well arbitrary bytes. It doesn't have pipe works with more than just ZFS is what I'm trying to say. But in this example, left hand side of the pipe is sending this snapshot and the right hand side is receiving it and storing it here. Now this left side does not have to be on the same server where the right one is. There are ways to transfer data between servers. So that's what I'm trying to illustrate here, that ZFS send and receive can be a really cool backup procedure. Oh yeah, and it supports how it's called. It supports incremental send and receive, so only differences are sent. And this is only done the first time, so you force basically this to become exactly as this. That's the idea. Okay, so I've been keeping you here for almost an hour. I know I started with something that is might be more advanced topic than it should be at the start. What I wanted to cover first is how do you back up? So, Snapshot is not a backup, but what I'm trying to say is if you uh, are backing up, make snapshotting part of it. And it's actually not if. Do backup and make snapshotting part of it. It's also useful for other stuff like boot environments that we're going to go over in the future. It's like having two different operating systems at the same time, uh, and it can save you of, uh, basically making your system unbootable by having a copies, but the least amount of data is copied. Uh, that's why I wanted to go over ZFS. And for the end, I said if something is from the package or port, there are few commands that I would like just to scratch the surface. Man package will tell you a lot of things, but there are like uh, different man pages. Like if you use git and man git this, man git that, it's kind of the same. So man install version whatever there is in a package. When I say whatever there is, for example, you can say give me package info and read what is in there and say, okay, this is what I'm interested in. So package info fish. Uh, oh yeah, I just saw the comments. Dtrace, yeah, it's gonna be too advanced for now. You know, we're covering basics, and it's kind of programming tool, but not yet, not really. But yeah. Anyway, sorry for the off topic. To see information on currently installed package, this is how you do it. To list the files. Oh, okay. I hope it's better. So this is how you list the. Oh, it ran off. Okay, this is dash L about the fish, and then it gives you the files. And maybe you just want uh, information about the install packages, like the list, which is huge, and you can pipe it through something called less, allow it up, uh, well, down and up arrows. You can uh, see the list, or you can say, give me anything fishy, and it's here. Let's say, okay, you want to remove a package. Uh, I just saw Chromium here in the list, so this is how you remove it, and it's gonna ask you about it. Let's say you want to install a package, right? This is how you would do it. I chose a kind of bigger one, so it takes time, right? And you can see this notice, like a message from. You can see that, uh, sorry, you can see that message like later if you say dash capital D. Or you can say, okay, give me that message for every single package. It's going to be quite a few of them. So pipe it through less, and you can read a bunch of them. As I said, maybe your installation was automatic on a server or somewhere, so you want to maybe catch up what's been installed and spewed out, right? Uh, so yeah, um, and about packages, install, remove. Oh yeah, maybe uh, there is something that you don't need anymore. Well, there is in this system. Maybe something was requiring it that doesn't require it anymore, so you auto remove it, and it's not it. Well, it makes your system cleaner, and you have package clean that is basically going to clean up the files that it downloaded, the files as a packages, and you can tidy up your system. So hopefully with packages, with some editing, with services and snapshotting, you are capable of managing your system a little bit, at least a little bit better than without snapshots, for example, or um, how to say, package something makes sense to me. If I want to install something, it's package install, right? It's not DNF do the magic. I don't know what package. I really appreciate the simplicity of this. Oh yeah, there is like a promise. I'm gonna show you how to see um, what are current vulnerabilities of packages on some system, like automatically how to audit. There is auditing of base operating system that it logs quite a few things, and yeah, there is security aspect that is done really nicely, that I really need to cover. Uh, that would be all for now. Uh, Next week, I'm gonna show you how to play with your snapshots a little bit more, how to uh, enable regular users to manage some parts of your snapshot, how to transfer between, I don't know, for example, virtual machine and snapshot on your host, simulating two different machines, so that you can know how to. The backup is the most important thing, so no wonder I'm starting with that. Uh, yeah, I have this habit of naming my desktop HAL 9000 for, wow, now more than 2 decades. So yeah, it's uh, it's an old habit. If I have a desktop, that's the name. Uh, but yeah, good catch. I even ignore it by now. It's like it's always there, so my mind ignores it. That I'm actually working on heuristic algorithm 9000. Oops, sorry. Yeah, that would be all for this week. Um, it's hopefully giving you more insight into what FreeBSD does to make your life easier. Uh, and we'll continue next week. And until then, take care, keep on hacking, and I hope it's in a virtual machine. Bye bye.